Greeting to our lecturer, Mr. Mohammed Fazli. My name is Wong from Group 13 of BEJ20503 Control System. My two members is Mun Feng and Abdihamid Mohamed. Today I will present about the Bode prod assignment. Okay, for my part, I will present the industrial application that we use for the project in question 1. So the industrial application that we use is Antenna Azimuth. It's shown at the figure in the slide. And Antenna Azimuth is a position control system that convert a position input command to a position output response. Position control system find widespread application in antenna, robot arms, and computer disk drive. The transfer function of the system of antenna as output is given by Gs equal to 1325 divided to S times S plus 1.71 times S plus 100. Okay, for question 1, the manual solution of transfer function of the antenna, we can get it in the slide. We convert the Gs to Gj omega Hj omega, and finally we get the Gj omega Hj omega is equal to 7.7485 divided to J omega times 1 plus J omega divided to 100 times 1 plus J omega divided to 1.71, and we get the breaking point at 1.71 and 100, and the K is 7.7485. For the 20 log of K, we get 17.48 decibel. For the starting point and the 0.01 rad per second, we get it as 57.48 decibel. Okay, in this slide, it shows 4 graphs with is the Bode prod by hand and using semi-log paper with corresponding magnitude and phase symptom. So this is end of my part. I will passing to my member Mun Feng to continue the presentation. Thank you.
Hi doctor, my name is Mun Feng. Now I will continue to present the question 2, the Bode plot at MATLAB. In the upper diagram that show the code of Bode plot. And first, I will call out the number and density. Then I will define out the system equal to transfer function in the bracket of number and density. Then I will call out the Bode in bracket of system. Then I will command the grep on that show the diagram after I run the coding. In the below diagram, they show the Bode diagram. In diagram, it have a magnitude diagram and a phase diagram of system. In this slide, they will show the result of correspond of hand sketches asymptotic plot. In the upper table, they show the magnitude plot diagram. In the frequency of 0.1, they have a pole at 0 have negative 0 degree dB, so the total slope have negative 20 dB. In the frequency of 1, they have a negative 20 dB in 0 and 1 pole, so the total slope is negative 40 dB. In the frequency of 1.71, the pole at 0, 1, and 1.71 also have negative 20 dB, so the total slope is negative 60 dB. In the last of frequency 100, the off pole have a negative 20 dB, so the total slope is negative 80 dB. In the diagram of below is phase Bode diagram. In the frequency of 0.171, the pole at 1.71 is negative 45 degree, so the total slope is negative 45 degree. And in frequency 10, The pole at 1.101 and pole at 100 also have a negative 45 degree, so the total slope is negative 90 degree. In the frequency of 17.1, the pole at 100 have negative 45 degree, so the total slope is negative 45 degree. In the frequency of 1000, that doesn't have any degree in any pole, so the total slope is 0 degree. Now, this slide is present the question number 3. The Bode plot obtained gain margin and phase margin at MATLAB. In the upper diagram, they show the code of Bode plot. First, I will call out the number and density. It will display the G equal to transfer function in the bracket of number and density. Then, I will call out the border of G and the graph. And last, I will command out the margin of G to display the gain margin and the phase margin. After I run the code, the diagram below will show. The diagram will show the Bode diagram that obtain gain margin and phase margin. We will get the gain margin is 22.4 dB and the phase margin is 24.4 degree. Now, I will pass to my group mate to continue the presentation. Thank you.
Thank you. My name is Abdihamid. So now I will continue my part, question 4. The diagram showed the gain margin is 22.4 dB at 13.1 radius per second, and the phase margin is 24.4 at 24.4 degrees at 3.4 radius per second. The way to get the first phase margin is look where the system crosses 0 dB at the margin diagram and comes down, and look for the distance at the phase diagram between the curve until negative 180 degrees is 24.4 degrees. The gain margin is the amount of a gain where the phase crosses negative 180 degrees. So we look for where the system crosses negative 180 degrees at the phase diagram and go up and look the distance at margin diagram between the curve until 0 dB is 22.4 dB. For the stability, we can look at the diagram when the increased gain at the margin. The decrease of the phase margin means the system will always be stable. Thank you. That's all for our group.